Welcome to Chemistry with Dr. Z. I'm Dr. Z, and in this video, I'm going to talk to you about the conservation of mass and the formula mass. This is part of the quantitative chemistry. So, what is conservation of mass? So, there is a law called the law of conservation of mass that states that the total mass of reactant in a chemical reaction is equal to the total mass of the products. In other words, mass cannot be created or destroyed in a reaction. That means that the when there is no mass lost during a chemical reaction. Instead, atoms will join in a different way to form product. So let's have some example. If you have these two different elements in a reaction, so let's say this is hydrogen and oxygen. The hydrogen here are the white balls and the oxygen is the red ones. So you have two hydrogens and oxygen reacting together. When they react, they give you two new molecules of a product, which is water. So this gives you two water. As you see here, all what happened is that the atoms have been joined in a different way. So no, no atoms have been lost. They just joined together in a different way to give you the product. So in a balanced equation, the number of atoms of each element is will be the same on both sides of equation. So this is a balanced equation, and as you can see, there are four hydrogen on the left hand side of the equation for the reactant, and there are four hydrogens on the right hand side for the product, and there are two oxygens on the left hand side and two oxygens on the right hand side. So there is the same number of atoms on each side. That is why we need to balance a chemical equation, because no atoms are lost during a reaction. Also, since atoms are not lost or made in a chemical reaction, that means that the total mass of the product equal to the total mass of a reactant. So if we have a look at this reaction, if we react sulfur with iron and then we heat it, that will give us a product of iron sulfide. So if you react 32 gram of sulfur with 56 gram of iron, they will react completely with each other to give you 88 gram of iron sulfide. That means that there is no mass was lost. So all the mass, the total mass of the reactant, which are 88 gram, will equal the total mass of the product, which is 88 gram as well. So if there is a mass change, because according to the law of conservation of mass, no mass is lost, but sometimes you notice that there is a mass change. Maybe the products, the total mass of the products is higher than the total mass of reactants, or the other way around. So there must be a reason for this. So if the mass of the product increases, that means there was a gas from air that has reacted and the product is a solid or liquid. For example, if you react a metal like zinc in air and you heated it, so the when you do your calculation, you only account for the solids or the liquids, but you don't account for the gas. Oxygen comes from air, so it doesn't count. We don't count it when we do our calculation. So when we start with 1.3 gram of zinc, we end up with 7.5 gram of zinc oxide. So now you noticed that you started off with 1.3 and you ended up with 4.5. So where is the change came from? This is because actually 3.2 grams of oxygen from air reacted with zinc. And we don't account for this gas. This is why there has been a change in the mass of the product. The other case, if the mass decreases, so the total mass of the product is less than the total mass of the reactant, then the opposite happens, meaning that one of the product is actually a gas that has been evolved in the air, and you don't account for this when you do your calculation because we only can calculate the mass of solids or liquid. An example of that is the thermal decomposition of metal carbonate. For example, if you heat calcium carbonate and there is thermal decomposition, so that will give you the calcium carbonate is a solid, that will give you calcium oxide as a solid and will give you carbon dioxide. Carbon dioxide is gas and it's lost in air, so you don't account for its mass when you do your calculation because you cannot actually calculate it. This is when you do your measurement, not when you do your calculation. So if you have 100 gram of calcium carbonate and then you heat it and there is a thermal decomposition, you will find that your product is actually 56 gram of calcium oxide because the carbon dioxide is lost in the air. So this is why there is a decrease in the mass of the product. Now let's move on to talk about the relative formula mass. So what is relative formula mass? So elements in the periodic table have the relative atomic mass. So we know the relative atomic mass of the elements. So what about compounds, different compounds? Do they also have mass and how can we calculate it? We can use this relative atomic mass to calculate the relative formula mass for any compound and we give it the symbol Mr. So Mr is the relative formula mass of any compound. Mr is the total atomic masses of all atoms making the compound. So let's have some examples. So if we have something like magnesium chloride, and we need to know the exact formula mass of our compound before we start calculating its formula mass. So if it's written not in the formula mass, not in the chemical formula, but rather as word for the compound, you need to know exactly the molecular formula before you start calculating your formula mass. So in magnesium chloride, we have one atom of magnesium and two atoms of chlorine. So the relative atomic mass of magnesium, Ar of magnesium, equals 24, and Ar of chlorine, Cl, equals 35.5. So when we do our calculation, the Mr of magnesium chloride, that will equal the Ar or the atomic mass, relative atomic mass of magnesium, which is 24 plus 2 times 35.5 because we have 2 chlorine in magnesium chloride. When you do your calculation, you're going to find that the relative formula mass of magnesium chloride is 95. We can also calculate the percentage mass of an element in a compound because each element exists in a compound. We could have more than one atom of that element in a compound, and we sometimes need to calculate the percentage mass of an element in a compound. To do this, we can use this equation. So the percentage mass of an element in a compound will equal the relative atomic mass of that compound times the number of the atoms in the compound divided by the relative formula mass of the whole compound times 100 because we are calculating a percentage. It's very important. Again, I'm emphasizing that you know the correct molecular formula. So let's have some examples. So what would be the percentage mass of magnesium in magnesium chloride? So we just calculated the formula mass of magnesium chloride and we know the relative atomic mass of magnesium. We can find the relative atomic mass of all the atoms from the periodic table. So the percentage mass of magnesium, we're going to apply this equation will equal the relative atomic mass of magnesium, which is 24, times the number of atoms of magnesium in the compound, which is 1, divided by the relative formula mass of the compound, which we just calculated, and we found that it equals 95 times 100. You're going to find that this is 25.26%. So this is the percentage mass of the magnesium in magnesium chloride. So let's have another example which is a bit more complicated, which needs more calculation from us. So if there is a mixture containing 30% iron by mass, what would be the mass of iron chloride that you need to provide the iron in the 50 gram of the mixture? So you have 50 gram of the mixture, 30% of that is iron, only iron, and we need to know, if this is the case, how much iron chloride is there in that mixture. So we are provided here with the relative atomic mass of iron, which is 56, and chlorine, which is 35.5. So the first thing we need to know is we need to find out how many grams of iron is there in the whole mixture, which is the 50 gram mixture. So um, we said that there is 30%, so iron is 30% of the 50 gram, which equals 50 times zero point 0.3. So that will give us 15 gram. So there are 15 gram of iron. Then let's have a look at the iron chloride. So the relative formula mass of iron chloride will equal the relative atomic mass of iron, which is 56, times the relative atomic mass of the chlorine times 2, because we have 2 chlorine, so 35 plus 35.5 times 2. So that will give us the relative atomic mass of the iron chloride, which is 126. Now let's calculate the percentage iron in iron chloride. So the percentage mass of iron in iron chloride will apply this again. This equation will equal the relative atomic mass of iron, which is 56, times the number of atoms in the compound, which is 1, because there is only one iron, divided by the relative formula mass of iron chloride, which is 126 times 100, and then the percentage is 44.09%. So we know that the iron in the iron chloride is 44.09%. And we know that the total amount of iron in the mixture is 15 gram. So what is the total mass of iron chloride that will give us the 15 gram of iron? Then we can simply use our calculation, our mass to do this. So in this case, the mass of iron chloride that will give us, that gives us 15 gram iron, will equal the 15, which is the 15 gram of iron that we need, divided by the percentage of iron, which is 0.4409, and this is going to be 34.02 gram. That means we need 34.02 grams of iron chloride to give us the 15 gram of iron. And the 15 gram of iron is actually the 30% of iron in the 50 gram of the mixture. So we used the method of calculating the percentage mass of an element in a compound to find out how much of a compound do we need to provide us with a certain mass of that particular element.